Yeah, coming back. So we were discussing control loop and the delay in the control loop. So what are the problems if there is no delay in a control loop? So yeah, we'll start reading the next part of the book, the Kubernetes controller paradigm and control loop. We'll see how control loop looks like in Kubernetes. Yeah. So, so in Kubernetes as well, like we have a master and it has set of pods. Yes, pods are nothing but containers, and we need to like there will be multiple controllers in a Kubernetes. So Kubernetes is generally used to manage the containers. Okay, so let's say if a container goes down, it will try to bring up, or if there is a load, it will try to do load balancing. Okay, and It also, but it doesn't build images and stuff. There is something called kubectl which can be used to build the images, and like you could use normal docker and all with for image, and you could use kubectl to launch containers from the image. It also has various other functionalities, but this is basic. Like it does the orchestration of containers, and yeah, like even so, as we discussed, control loop. Okay, so when we are programming in IoT devices, we should be careful of while writing control loop because it could cause issues like wastage of energy or not achieving what we want. Okay, uh, so that's the thing. Like, and also interestingly, like in cloud orchestration, Kubernetes also has something like this, similar. Okay, so it's this control loop. So this is how it would be used. Okay, so there will be a controller. So it will be yeah, so we will tell. So the algorithm goes like this. Okay, so there will be controller. Okay, which manages microservices of multiple pods. Okay, and the goal is to achieve desired state. Okay, further service. For example, like maybe about scaling out. Okay, so it continuously obtains information, okay, about the state of the service, and it also checks if the current state of the service matches, okay, and tries to take appropriate action on the service. Okay, we'll go to the next one. So as we said, the Kubernetes controller needs to manage the containers. So or workers, okay, work pods, whatever you call it, and it needs to so it needs to know the state of the information, whether any node is up or is there any issue, okay, uh, or what. So whatever the user specifies the desired state of the system, is it getting achieved? So how does it read the current state of the workers? Is one question. So in order to do that, it needs to poll again and again, but we don't know, it might be still for hours together, okay, but you keep on polling, okay, unnecessary bandwidth consume and processing as well on the controller side. Yes, so there are and we don't know, there might be by the time I read, what would have happened, okay, so what if we don't need to worry about the delay as well. So in order to solve this, like Kubernetes controller uses like event driven approach. So in event driven approach, like controller doesn't need to ask anything about the current state. So whenever some change happens on the worker or container, it sends a message back to it emits an event or generates an event and sends it to this controller, okay, so controller reads it and just note it down, okay, and also checks if the desired state is reached or not, okay, and it tries to like adjust the system, okay, to move towards the desired state, okay, so the control loop will have wait for message, and only if the message if there is some specification change, then only it will do the next step. Until then it won't, so the wait so the waiting is like indefinite until a message comes. Yeah, that's all it is. This is called as controller paradigm, and so here there is no polling, okay. So we'll read the next thing: components of Kubernetes control.